I understand London is creating a board on digital cities. Can you tell me more about that?
Yes, it's actually called the smartboard London, and the mandate of the board is to really oversee how digitally enabled technologies are being deployed across the entire city. So deployed across, for example, underground, at the surface level, and in airspace. So the types of technologies are breathtaking. Everything from sensor technologies to take a look at how infrastructure is being used. For example, bridge fatigue to reduce the number of inspections required, to looking at traffic patterns and also transportation with trains. So that, in addition to that, there's also a lot of work on predictive analytics to try to understand how the data patterns will actually change the policy on how the city should manage its resources. The board consists of roughly 20 commercial companies and the various cities' departments. So, for example, the Department of Transportation, represented by London Tube, and also some of the city departments on urbanization development. So, for example, one major project is creating of a digital campus on the west part of the city. The digital campus will have a variety of different corporate R&D centers, technology groups, and entrepreneurs and startup environments to solve digitally cities-based problems.
What sorts of emerging technologies will start to be implemented in digital cities?
Well, the range is pretty extensive. It goes from material sciences involving what we call metamaterials, where you could have very different properties of changing how energy is manipulated by materials. When energy strikes a material, for example, it's possible to harvest some of that energy to create sensor arrays and disruptive sensor arrays at a very great scale, to predictive analytics, looking at human behavior dynamics and everything in between. So it crosses software, hardware, technologies. The real important point is the convergence piece, where the convergence is creating a unique cut across the information that is delivered to the city about what it's actually doing.
At the core, do you think it is all about the data?
I believe that, yes, it is all about the data. In order to be able to get to the data, you have to have other types of analytic tools, predictive analytics and privacy-preserving analytics, but you need to have the sensors to be able to accumulate the information. So, for example, there's a global spend of roughly $4 trillion on infrastructure development underway, but the penetration rate of technology into the infrastructure is only 6%. Part of the reason that it's only 6% is because people really don't understand the role of emerging technology and how to actually make it work to create the data sets to do the analysis after the fact. So, for example, there's a lot of work right now just trying to understand predictive analytics in the big data world. How would predictive analytics enable you to change the way a city operates, or what the dynamic is among the population?
And what are the various companies' roles, and how is PARC different? What's PARC's role on the board?
PARC's role is to be that of an advisor, just like some of the other companies. So because PARC is uniquely positioned in the early space of innovation, especially around emerging technologies, because we cross both hardware and software capabilities, we're in a unique position to be able to provide advice on where the technology is moving. That's really important because the planning horizons for these companies are 3 to 5 years, and in some cases for the government, it's 5 years plus. So they need to understand where to put relevant investments today by looking at where the emerging technology is going to go into the future.
You mentioned privacy. So what are some of the solutions to addressing the privacy fears that people tend to have?
Well, there's a term that's being used called theater of privacy, and what it really means is that we are all actors on a stage talking about the need to protect privacy, but while we're doing that, a lot of the corporations themselves in creating all these devices are moving well past that. There's no national policy or global policy on how we want to deal with privacy. So as an example of that, there's a consortium of technology companies in Silicon Valley, which include Microsoft and Apple, that are challenging government requests for data from iPhones and other mobile devices to combat terrorism. And that presents real privacy issues, even though it's an incredibly important issue for us to try to understand. And the policies that come out of what the government wants to do could also include things like backdoor software to be built into systems. These companies oppose that because they understand that their customers will not tolerate that invasion in privacy.
What are some of the barriers that this board is seeing? And are there other models of digital cities in action? And what are some of the barriers that are?
Digital city boards are beginning to emerge. It's a new concept. So the City of London is probably one of the more progressive in that arena. There is a consortium of roughly 25 European cities that are now looking at the London model and developing their own approach to smart cities. Smart city and digital city are used interchangeably because in the early days, smart city was a term that was coined by IBM in providing government services, and it's been adapted. I prefer to use digital cities because it really gets to the heart of the issue. Digitally enabled technologies that enable a city to be smart, and that's really where the emphasis should be placed.
So in David Aggas's book, The Lucky Years, he talks about data and how all of this collection of data will make people's lives better. How do you see that playing out in a digital city?
Well, he gave an example of looking at how noise and in urban environments affects the incidence of Alzheimer's. So because medical records are now digitized, you can take normalized data out of the records to see patterns that emerge. You can look in cities, you can look at busy locations near airports, and you can see what the incidence of Alzheimer's is relative to other parts of the city. And what they discovered was there indeed is some kind of a pattern related to noise levels that changes the dynamic around Alzheimer's. The more quiet you have, the better sleeping environment you have, the less chance you have of developing early stage Alzheimer's. So that's one example out of his book. He gave many, many examples crossing a whole different area of predictive analytics and what the implications are in medical health care and treatment. So one kind of conclusion one could draw, if you get the right data and you can really understand how disease patterns operate within a city, you can then make decisions about where to locate hospitals and specialty services for medical treatment.
So this is really a holistic, a ginormous approach to creating a new way to live. How does a board like the London board start? Where do you begin?
That's a really great question. And you know, the problem is that you have disconnected data sources right now. So for example, you have some 20 million commuter records that the London Tube has on the commuting patterns of their customers. At the surface level, you have Telefonica and O2 that have a lot of data on how people work at the surface level, and then in the air, you have sensor data, and then you have TV data, but it's all Chinese puzzle pieces. It hasn't been integrated together in what I would call a holistic view of how the entire city would operate. And the real key value is when you actually cross the different data layers and see new patterns that develop. So for example, if you have all this information about how people are commuting into the city, and you connect it to the surface level with cell phone capability, you could actually direct people to different stations if there's a problem, for example, with a train stopping in a particular tunnel causing congestion. So it's really simple problems, but it's really about connecting all the different data sources into a coherent view of how the city's operating. That's really the vision of where they want to get to. The start of that is really starting out with experiments. So the Smart City London Board has a series of experiments. For example, they created something called the Open Data Institute, or are working with the Open Data Institute. And they took some National Healthcare Service data sets with the assumption that pharmaceutical drug delivery was relatively equal throughout the city. ODI took that data set and did a equivalent of a hackathon using the information and discovered that in fact there's a lot of disparity of pharma drug delivery to people based on income. And so it can change the way you look at policy, it can change the way you think about distribution of medical care. That's really the first series of experiments to prove that the model can work. Once there's proof the model can work and you get new insights into how a city operates, it can then be expanded to other areas such as infrastructure.
So this is really bigger than a digital city. It's really taking all the technologies that have been formulated over the last several decades and changing our lives into the future.
Yes, it is, but you have to remember the demographics. Worldwide, urbanization is growing at a rapid pace. People are moving into cities. So you have a really densely populated area, small area relative to some of the larger regions, and it's an area that's extremely well connected. So it's possible in a very short period of time to have a huge impact on the population when you start integrating technology. You're not going to do this in the farmland or in the middle areas of a particular country.
You've given a few examples. Can you think of a couple more that you'd like to highlight with respect to travel, tunnels?
Yes, well, there's a lot that's happening across the world, especially in China. There's over 108 major infrastructure projects of $1 billion or more underway, including the building of a regional series of airports, everything from one of the longest tunnels in the world under ocean. a lot of work that's being done. And so this is not, by any sense of the imagination, a small market. It's a rather large market. Over $4 trillion a year in infrastructure projects and only a 6 to 10% penetration rate of technology. So the first thing is to be aware of that fact and find ways that technology could be embedded into even more infrastructure through a plan where you're integrating to get benefits for the population of the urban centers. But you're also concerned about things like privacy-preserving analytics to keep people's information private while you're also trying to deliver insights and benefit.
So you've talked about London, you talked a little bit about China. Where in the U.S. can we go and take a look at some advancements in this area?
Well, that's already beginning to happen. So for example, in Seattle, they did an analysis of what used to be called the Alaska Highway, which was an elevated highway system that went right through the downtown area. And they did an earthquake simulation which showed what would happen if a 7.8 earthquake struck anywhere near the city edge. And it was very devastating in the video. It used real-time physics to estimate what it would look like in terms of real damage. And it was a devastating impact to the city if that were to occur. So as a result of that, they decided to look at a tunnel concept, and they wanted to do simulations to see what that would look like and then apply real-time physics to it to see what traffic patterns would look like. So Parsons Brinckerhoff, one of the key vendors, developed all the software technology and data analytics and predictive analytics really to allow the city to begin planning a completely new approach to how it wanted to design traffic patterns through a tunnel in the center of the city. They're now applying that also to 2 bridges that are being revised and constructed on Lake Washington.
So you'll start to see this play out with many projects that have a specific goal in mind, and they'll use all these technologies to implement it.
Yes, I think that the real key to this is now the hardware and the sensors are delivering new kinds of data, and it's crossing that data layer that actually creates the insights. But it's becoming really an exciting time, especially in predictive analytics, because the insights are real and they can change people's lives and the quality of people's lives. As an example of that, just one example, there's a project called the London Crossrail Project, which is a high-speed train that's being built as we speak under the City of London, 160 kilometers of new tunnels being built, connecting all of the various terminals to allow London and the UK to be directly connected to Europe and the Eurostar. And so that project, even though it's going to cost £14 billion when it's finished, is estimated to deliver approximately £20 billion of value, economic value, to the city every year. So it's really an exciting time to take a look at what's happening with digital cities. We're really at a crossover point where I believe we're going to see more and more of this developing. And with the new 25-city consortium in Europe, I think it's going to expand pretty dramatically.
What's PARC's unique role in advising the board on digital cities?
Well, PARC is really focusing on offering advice about emerging technologies and how it can be employed by the city in a lot of these digitally enabled projects. PARC has a kind of unique business model in that we do work for DARPA, the government. We also do work for commercial companies where we're taking early stage technologies to help drive innovation. And then the third leg of that is academia. So we work with universities like Stanford University. I'm a resident scholar there as an example of that. But we do a lot of collaboration. Our researchers, over 250 researchers throughout PARC. And then in addition to that, we work with some of the European universities as well. So we have kind of a very unique way of looking at how emerging technology can drive innovation without actually competing with any of the board members. We don't create competitive projects or products.